Okay, problem one. Which of the sequence will converge? Which will diverge? So what is a sequence? Sequence is just a list of numbers. Okay, for example, let's say a sequence like 1, 2, 3, 4, etc., etc. Right? And will this sequence be convergent or divergent? Clearly, it will be divergent. Divergent just means it's not closer and closer to a specific number, because you can see as the sequence goes, the number will get larger and larger, right? So it will not converge to any specific value. So it is divergent. Another type of divergent sequence is like, for example, 1, -1, 1, -1, etc., etc. Right? You can also see this type of sequence, the value is alternating between 1 and -1. Right? So again, it's not closer and closer to any specific value. So it is also divergent. Okay, what about a convergent sequence? For example, 1 half, 1 over 4, 1 over 8, 1 over 16, etc., etc. You can see for this sequence, every term is half of the last term, right? This is half times 1, this is half times half, this is half times 1 over 4, etc., etc. And you can see this sequence, it's convergent, right? And it's convergent to the value 0, right? As the sequence goes, you can imagine this sequence is going to be closer and closer to 0, okay? So how do we know a sequence is convergent or divergent? We just need to figure out its limit. Okay, for example, 1a, it's 3 plus 5n squared over, okay, over n plus n squared, over n plus n squared. So we just need to get the limit of the sequence when n is approaching infinity, right? If that limit is any real number, then the sequence is convergent. If that limit is either infinity or negative infinity, or the sequence doesn't even exist, then it is divergent. Okay, so it's a limit n is approaching infinity, 3 plus 5n squared over n plus n squared. Okay, so it's a limit n approaching infinity. So how do we get this limit? Because both are polynomials, so we can divide both sides by n to the highest power. Right? So the top is this, and the bottom is this. So now when n is approaching infinity, this is 0, this is 0, so the result is 5. Okay, so the limit of the sequence is a number, so the sequence is convergent. Okay, so the sequence is convergent. Okay, let's do part 2. An is 7 to the power of n plus 5 to the power of n over 1 plus, right, 12 to the power of n. So again, how do we determine the sequence is convergent or divergent? We can just get the limit of an, right? And here we can divide both sides by 12 to the power of n, right? Because if we do that, we have 7 over 12 to the power of n plus 5 over 12 to the power of n. Okay, over 1 over 12 to the power of n plus 12 over 12 to the power of n, so it's just 1. Okay, and when we do this, we didn't change the value of an, but after we've done this, when n is approaching infinity, it is, right, a number that is smaller than 1 to the power of infinity, that's going to be 0, right? This number smaller, right, so this part is also going to be 0, 0, but only this part is 1. So it's 0 over 1. So 0 over 1, the result is 0. Okay, again, the limit of an, it is a real number, so an, it is a convergent, right? This sequence is convergent. Okay, the sequence is convergent. What about part 3? Part 3, an is ln n over ln 2n. Okay, again, we want to get the limit of the sequence. So it is ln n over ln 2n. So how do we get the limit of this sequence? Now we want to, right? So it's first just try substitution. It's infinity over infinity. Okay, it's infinity over infinity, so we want to try substitution. Okay, I'm sorry, infinity over infinity, so we want to apply L'Hopital's rule. Okay, but before L'Hopital's rule, we should change this limit of the sequence to the limit of a function. Okay, so why do we need this step? Because these two, they look like the same thing, right? Why do we need this step? Because essentially when you apply L'Hopital's rule, we can only apply L'Hopital's rule to a continuous function. We can only apply that to a continuous function. So we can only apply that to a continuous function. That's why we, that's why we have to change this to a continuous function, because here it is a sequence. Okay, it is essentially ln 1 over ln 2, ln 2 over ln 4. It is a sequence. Okay, it is a sequence. But here, if you change it to x, now it's a continuous function. And it's a continuous function, we can apply the L'Hopital's rule. You differentiate the top, you get 1 over x. Differentiate the bottom, you get 1 over 2x. So they can be canceled out. The result is 2. Right? The result is 2. So, okay, sorry. The result is 1. Because if you differentiate the bottom, you get 1 over 2x times 2. Okay, because of the chain rule, first ln something, the derivative is 1 over that, and then 2x, the derivative is just 2. Okay, so the result is 1. Again, it is just a real number, so an is convergent. Okay, so an is convergent. So to figure out whether a sequence is convergent or not, just find the limit of an. Okay, if it's a real number, then it is convergent. If it's, for example, unfortunately, if we get infinity, or if we get doesn't exist, then it is divergent. Okay, then it is divergent.